today introductory class, we will basically deal on some basic concepts in chemistry. We'll look at the first 20 elements, their atomic number, their mass number, number of protons, and number of neutrons. Basically, we're just going to start from the basis, then we'll grow the class. Now we're going to consider the first 20 elements and their symbols. Looking at here, you have hydrogen with the symbol H, helium with the symbol He. Those elements that has two symbols. Basically, what you do is that the first letter should be in capital letter, while the second letter should be a small letter, lowercase. For those elements that has two symbols, like hydrogen has only one symbol, so the first letter should be H. So you have hydrogen with H, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, till you run to the 28th element, which is calcium. Now, these are the first 20 elements. Now, we're going to look at their atomic numbers. Now, basically, if you look at hydrogen, which is the first element, the atomic number is 1. So, if you want to place it serially, the first element is the atomic number is 1 because it's the first element, 1. So looking at here, hydrogen atomic number is 1 because it's the first element. So the atomic number is 1. Helium, the atomic number is 2 because it's the second element. Now looking at lithium is the third element, which signifies that the atomic number is 3. Beryllium is the fourth element, the atomic number is 4, till you run down to the 20th element, which means the atomic number of that particular calcium is 20. So this is how you identify atomic number of the first 20 elements, or 30 depending, but I'm just considering only the first 20. So when you go through the periodic table, the serial number of that element in the periodic table signifies their atomic number. Now, having identified the first 20 elements with their atomic number, now what we're going to look at is how to identify the number of protons, the mass number, the number of neutrons. So, as a recap, atomic number could be defined as the sum of protons in the nucleus of an atom. Now, what does it mean? It means that if you are able to know or identify atomic number of any element, in the same vein, you also know the number of protons. What it means is that, for example, hydrogen, the atomic number of hydrogen is 1, and we define atomic number as the number of protons. It means that hydrogen also has number of protons as 1. Atomic number 1, number of protons is also 1. So looking at this, atomic number, number of protons, you're all saying the same thing, just different name. So for hydrogen, atomic number is 1, number of protons is 1. For helium, atomic number is 2, number of protons is 2. For lithium, atomic number is 3, number of protons is also 3. So I think that makes sense now. And you run down to the first 20 we are just considering, number of protons is the same thing as atomic number. Now let's look at what is mass number. Now if you look at this first 20 elements, you have some values that are written above each of these elements with different color, just to signify. So these numbers written in blue, these are known as mass number, or you can call it atomic masses. I repeat, you can call it mass number or atomic masses. So these are the numbers written in blue. These are what we call mass number. And in a layman understanding, you can define mass number as the sum of protons and neutrons. It's the sum, that's the addition. When you add the number of protons to the number of neutrons, it will give you your mass number. So for example, hydrogen has a mass number of 1.00. Helium has a mass number of 4.00. I just take it to 2 decimal places, more than that anyway. But some periodic table actually approximates to the nearest whole number, but I don't want to do that because there's a reason for that. So for helium, 4.00, lithium, 6.94. So these values are known as mass number, which is the sum of your number of protons and number of neutrons. So while you add them, you have your mass number. Now, let's take a look at how do you identify the number of neutrons then. Now, to get the number of neutrons is just the difference between the mass number and the number of protons. The difference between mass number and the number of protons. Now, let's take a look at this. Now, look at this representation. It's just a replica of what we have here. Now, look at this. The A, the Z, and the X. What does this signify? When you see an element written in this representation, what does it tell you? It means that what is up here, A here, stands for the mass number. Mass number. So this is the mass number. You can call it mass number or atomic masses. Don't mistake it with atomic number. You can call it mass number or atomic masses. That's this A here. Now, this Z here, which is down, stands for what? Atomic number. This stands for atomic number. If you don't, you can call it atomic number or number of protons. Because remember we said atomic number also means number of protons. So Z represents number of protons or atomic number, while the X represents the symbol of that particular element you're looking at. So for example, let's use sodium. Now look at sodium. You have sodium is 22.98. Then you have 11 here. Now, looking at this, you can identify the mass number. So what is the mass number of sodium? The mass number of sodium is 22.98. Some approximate it to 23, but let's keep it at that, 22.98. That's the mass number of sodium. Now, what is the atomic number of sodium? The atomic number of sodium is 11. What is the number of protons of sodium? The number of protons of sodium is 11. Now, how do we identify the number of neutrons? So for you to get the number of neutrons of sodium, you just simply, you subtract 11 from 22.98. That gives you the number of neutrons.